Our muscles are capable of performing a large variety of tasks, from propelling us into the air, to landing safely, or to just holding us up against gravity all day. Each of these tasks has different force needs. So let's start with a review of how muscles generate force. The primary components responsible for generating force within muscle are actin and myosin. In the presence of calcium, the actin and myosin fibers will bind to each other. The myosin heads use stored energy to pull the actin fibers along. The cycle repeats as long as force is needed. Once the force is no longer required, decoupling happens and the muscle returns to its resting length. Not all activities require muscles to simply shorten. There are times when muscle must lengthen while it's contracting, or must hold a static position to provide stability. Therefore, our muscles contract in different ways based upon those needs. Let's examine the different types of muscle contractions. With an isometric muscle contraction, we have no change in length of the actual muscle. Since the muscle is not changing in length, there's no motion occurring at the joint. In order for muscle to be able to maintain its static length, we need to have binding between the myosin and actin fibers. However, no power stroke happens, which is going to cause shortening of the muscle. Isometric muscle contractions are very useful to provide stability around a joint or to protect a joint. Let's look at a couple of examples. In this example, the wall keeps the shoulder from moving through further range of motion, however the muscle is contracting. Since there's no change in length of the muscle, this would be considered an isometric contraction. Here we have a hip abduction isometric contraction. It's important to understand the isometric contraction does not start until the joint is unable to move, when the foot is in contact with the wall. Isotonic contractions mean same force. They allow for motion occurring in a joint. They can either be concentric, where the muscle shortens, or eccentric, where the muscle is lengthening as it contracts. Let's start with concentric. Concentric muscle activity requires the muscle to shorten in length. As you can see, we have our actin and myosin binding, resulting in an overall shortening of the muscle length. These contractions are primarily used to get a body part moving against gravity or some other type of external resistance. With a concentric contraction, motion occurs in the same direction as the primary function of the muscle contracting. In this example, our primary muscles contracting are our knee and hip extensor muscles. Therefore, since the muscle is shortening, both the knee and the hip are moving into extension. Let's contrast that with eccentric muscle contractions. During eccentric muscle activity, the muscle is lengthening as it is contracting. Eccentric contractions are used to slow down a body part or control its motion against an outside force. In this case, our cross-linking allows for a slow, controlled lengthening of the muscle. In this example, our shoulder flexor muscles are eccentrically contracting. With an eccentric contraction, motion occurs in the opposite direction of the prime function of the contracting muscle. In this example, our hip and knee extensor muscles are contracting. However, the motion that is occurring is the opposite. So during this movement, we see hip and knee flexion. Since flexion is occurring, the extensor muscles must be lengthening. In this example, the force of gravity drives the knee and hip into flexion. Eccentric contractions are necessary to make sure we do not fall out of control. The last type of contraction we'd like to discuss is isokinetic. Iso meaning same, kinetic meaning speed. True isokinetic movement is rare during daily tasks. However, isokinetic testing and training is commonly used in the rehab of injuries. Isokinetic training requires the use of a machine that can control the speed of motion. With an isokinetic machine, the speed remains constant, regardless of the force used during a push or pull. Isokinetic machines are capable of training almost every motion the human body is capable of performing, and are capable of being used with both eccentric and concentric muscle contractions. The dynamometer ensures the motion occurs at the preset speed. One of the benefits is that muscles can be trained at higher speeds, which simulates muscle function needed during higher level activities. Another benefit to isokinetic machines is that the range of motion for training can be controlled. This can allow for protection of a joint during the rehab process. Now let's review our types of contraction. We have isometric, where the muscle doesn't change its length. This is useful for stabilizing around joints. We have isotonic, which includes concentric, where the muscle is shortening, and eccentric, where the muscle is lengthening. This is where most of our motion occurs. And finally, we have isokinetic. Isokinetic refers to contractions that occur at one speed. Hopefully now you have a better understanding of the different types of muscle contractions and how they benefit us during our daily activities.